My name is Xinshu. So the name for the company is Zilliqa. If you are curious, the meaning of Zilliqa is something like silica or silicon, which powered the whole computing industry. So we put our vision into Zilliqa, and we think it will become the empowering platform for the next generation high throughput apps on blockchain.
Okay, and this is an interesting idea because blockchain and high throughput are not always two terms that are associated with each other right now. A lot of the kind of known options tend to lack high throughput. So what are you doing to fix that problem?
So we want to improve something called throughput, basically, how many transactions you can process every second, with a very secure approach. So that means, we don't want to say, okay, we improve the throughput, but then at the same time, we sort of make the system less resilient or less secure. So that's something we don't want to do. So that's why we really carefully design our protocol. We use some idea called sharding. And sharding is a very high-level concept. We can talk more about it. But then how do we design your sharding very securely and efficiently so that, when you improve your throughput, and then at the same time, you still maintain very strong decentralization and security for your blockchain. And, after you do sharding, you still need to make your consensus protocol within each shard very efficient. So that's where, we use some other techniques to sort of reduce the size of the messages and change the topology of the network to make it really efficient. So these are some of the techniques we use in our blockchain protocols.
So just I actually in the past I have worked with some distributed databases who also follow the concept of sharding. Is it pretty much the same kind of concept as anyone who's used any other distributed system, or are you using a similar term but to mean something slightly different?
I think the idea came from the sharding idea in the database field. So, but then of course, database is just about data, right? So when you apply the same idea on the blockchain, which does not just have data, but also has computing, also has validation, also has smart contracts, things just become much more complicated. And then you will have to sort of invent or innovate in the way you deal with these new challenges when you migrate the sharding idea to the blockchain.
And so just to reiterate that, just to double check, also, firstly for people who may not know what sharding is, but also just to drill into the details of how you implement it. So with a distributed database, you tend to partition. A shard is what's called a horizontal partition of data. And it's typically in a database where you split the rows of a kind of collection or a table or whatever it may be in the database. So that kind of means like, say it was a database of event logs, then you might shard by year or something like that. So with a blockchain, well, I guess it's going to depend very much on how someone uses it. But is it a similar principle? You just shard the data by a particular arbitrary key or something like that.
I mean, you can think of it that way. So, for instance, you have these things called transactions in the blockchain. So, in the very most basic form, it's about one account transferring some asset to another account, or in Bitcoins, some unspent amount of tokens transferred to another address. So if you look at that, you can actually segregate different sets of transactions into different so-called shards. So the way you segregate is something you just discussed, whether it's according to some attributes or it's according to a certain, sender account or things like that. So there's no, definite answer to how you shard. So actually, that's one of the parameters you can tune to get better, performance or security.
And so let's go back to the consensus side. I mean, again, in distributed databases, there's a concept of consensus. It's not called the same thing, but there is a concept of determining which write to which shard or which node is correct or not. If the various shards ever get separated somehow. So how do you work with something like that? Is the The consensus is the consensus algorithm available on every instance, or are there kind of the concepts of like masters and slaves or something like that?
You know, at the very high level, I guess the so-called consensus algorithms would be not fundamentally different from similar things in the database, because it's all about getting a sort of consensus view, or a view in agreement, a view in common among different computers who may have slightly different views, right? So it's all about that. And one potential difference in the blockchain is that you need to assume some stronger attacks, I would say. In the database environment, you can have other ways. You can have other cybersecurity measures to make sure that maybe attackers won't get in, or even if they get in, they won't be able to control more than, let's say, 1% or 5% of the machines. But then these sort of assumptions may no longer hold in the public blockchain. Usually people would assume you have 1/3 of nodes who can become malicious, or sometimes they even say 49% of the nodes may become attacked or compromised. So that's something you have to take into account. That's why the consensus protocols in the blockchain sometimes are more robust, but then that also means you need to take more time to reach the consensus.
Let's have a quick look at some of the features that you claim, and then we'll sort of drill into a bit more detail about how they might work. So the scaling aspect is one. And then you're also talking about data flow smart contracts designed with high parallelism, which makes sense, atomic commits, and a user-defined security budget, which I guess is sort of what you were just alluding to. But maybe if you could go into a bit more detail about what that means, and I guess, are you using your own custom language for the smart contracts, or have you adapted something like Solidity, or
Yeah, sure. Let me talk about it. So what we're working on for the smart contract part is we're designing a new language. It's named Zilliqa. The whole purpose is not to design yet another new language. It's really about, we want to look at the fundamental limitations of today's smart contract languages, and then we see how do we solve this problem. So one clear problem to us is today's smart contract languages, such as Solidity, are way too complex. So they're very rich, they are very expressive. That's a good thing for the programmers, but then it's really hard to sort of, we call it reason about it, we call it verified, but it's really about how can you be sure that when you write a program in that language is correct, and it really does things you want it to do, and it only does such things. So that's very difficult with today's smart contract language. And we think, fundamentally speaking, you have to have a different language which is more formal. When I say more formal, that means it's all about its amenability to verification. So, for example, in our language, we model smart contracts as student machines. So that means people can stipulate what exactly are the possible states the program may run into, and then the transitions between different states will be sort of defined as these triggering events. So in this way, you can imagine when you write a smart contract in that language, you know exactly what it's going to do, and then you know exactly why this smart contract is doing a particular thing, because it's moved from the previous state to the new state, and then the triggering event just occurred. Otherwise, it wouldn't even make the transition. So this makes security and correctness reasoning about a particular smart contract much easier. So that's the whole idea of having this new Zilliqa language. But we understand people will have difficulty learning a new language, especially this language is so mathematical. So we were trying to do some work. For example, we want to make a tool chain or compiler to convert from a Solidity-like syntax to this new syntax of the Zilliqa language. So that's just to ease the programmer experience.
Okay. And actually, I've just started digging into your code base a little bit, and as far as I can tell, everything's open source, which is always good. It looks like it's written in your main core anyway is written in C, as far as I can tell. C++.
C++.
That's what I meant. And it looks like, as far as I'm seeing something which I've not heard of, called level DB as a dependency. I'm guessing that's a database of some description from the name. Is that something you created, or no? It's a Google project. No, it's a Google project. And what are you using that for?
We only just use that as a local database. So on each node, we need some mechanism to store the data. So that's just something we are using.
Okay, no, fair enough. Just checking. And I'm guessing, did you opt for C++ for the speed, so to match the high performance requirement?
Yeah, that's one thing. Another thing is, as hardcore programmers, we really want to have full control over the systems or access to system calls, so things like that. So we just feel like C++ gives us low-level access to the system APIs. So we know when something goes wrong, we know exactly where.
And if you have any rough idea, what will the smart contract language look like? Will it be a sort of script style language, or what's I suppose if you want to contribute to the Zilliqa code base, you need C++, which is a little more complex, but to create the smart contracts, what's the kind of level of coder you're aiming at?
For programmers, they don't have to learn a new language. They can just write something like Solidity, and then we'll do the conversion. But then if you want to dig into this new language, it will be something like state machine. You describe what are the states in your program, and then how different states may transit from one to another. So we are going to release some examples to show people how this works. But in general, I think programmers don't have to worry about learning a new language.
Okay, and actually, let's talk about that. So the project is relatively new. I mean, most blockchain projects are relatively new. So, in the scheme of things, you released a white paper last August. You already have an internal testnet and a public testnet. The source code was released in January. And you're aiming for the main network to be launched in Q3 of this year, that would be coming up in a few months. Yeah. So, when can developers get their? Well, actually, maybe a better question is: with the testnet, can developers already experiment with what you have to offer, or will they have to wait for testnet version 2 coming along soon?
I think they need to wait for a little bit more. Now the simple APIs are just for sending transactions, checking records or things like that. So it's really just about asset creation or asset transfer. It's not yet about running a complex program. But we are going to try to show something by next month. But then don't expect a full-fledged Scylla implementation. But at least people can understand how the experience would look like if you want to program in our new language. Then after that, of course, we'll try to integrate that new Scylla language to our sharded blockchain and make it very efficient in terms of runtime.
Okay. And there's a few projects that have been attempting to solve this kind of blockchain scaling issue for a while. I guess the first question related to that would be, how do you compare to some of those? Who would you consider I don't want to say competitors, because the blockchain space is still fairly open and complementary, but who would you consider your close similarities, and how would you differ from
them? So if you look at today's high throughput blockchains, or proposals of high throughput blockchains, so one idea is you try to reduce the number of nodes who make the decisions, right? Because in that way you can get confirmation or get consensus much faster. As I already explained, we sort of want to take another approach. We want to say all nodes in the network still need to participate in this consensus process, and the result coming from our approach is the whole process is still largely decentralized. And we like that. It's good. It's good for many reasons. It's good for being more resilient against attacks. It's good for being stronger when your network run into some issues. And then it's also good for sort of some applications to be implemented. Otherwise, if it's all centralized, people would be wondering, why would I need a blockchain in the first place? So we still want to go with these original ideas or the original beauty of the blockchain, where things are largely decentralized. So that's one comparison with several blockchains. And then there are other solutions who are not just improving the blockchain throughput per se, but then they can run things much faster in a semi detached manner. It's called state channels or payment channels. You have a Readon, Lightning, or Trinity for Neo. So the idea is you can run some of these transactions off the blockchain with different payment channels, pairwise channels. I think these are very promising directions to explore, and I do think the speed of the blockchain is not going to satisfy all requirements. So for small payments, I think payment channels will really be useful, but that's not our focus. Our focus is really to try to improve the fundamental throughput of the blockchain itself.
Okay. Yeah, it kind of makes sense. I mean, that's one of a lot of these sidechain projects are very interesting, but it starts to get quite complicated and confusing when you have all these branches of chains going off. And the more complexity you introduce into the system, the more complexity a developer potentially has to deal with as well, in verifying that the inputs and outputs are matching up, and et cetera, et cetera. Your idea is actually relatively simple in comparison, and you're using concepts that are not new, and that's not meant as a negative. That's meant as so many people in the blockchain space keep trying to reinvent things that distributed projects have existed for decades. You can take learning from distributed projects that have existed before and make them work in a new space. It's not something you don't have to reinvent everything all the time. You can just iterate on it.
Yeah, but there's also lots of innovation we have to do, especially at the engineering level, to make things really work fast.
Yeah, innovation isn't the same as reinvention. Maybe I'm not sure if that's
right. Yeah, exactly.
I mean, there's plenty of companies that are classic examples of that. They innovate on existing ideas, but that's actually on one sort of major difference between what you're doing and say these older existing distributed systems is, of course, the sort of the tokenization, the token system behind many blockchain projects. So I've just come across a blog post from December of last year that goes through the details of your token mechanism and system. So maybe you could explain that a little bit. How will your token system work, and how does it relate to the core project?
So our token is not special in the sense that it's very similar to Ethereum, Ether tokens. So So when users want to send transactions or run smart contracts on the blockchain, they will have to pay sort of a gas fee in our tokens, and then such tokens are transferred to miners. But on the other hand, in the first few years at least, the blockchain system itself also will generate some awards for miners. So that's also very similar to Ethereum. One key difference is that the mechanism we will award miners will be much more evenly distributed. It's not like one winner who will take all. It's more about we will divide the mining rewards for each block, and then we will sort of almost evenly distribute the portion of the rewards among all nodes who contributed for that block. So that's a key difference. So in that sense, you in principle do not require mining pools because you already get very evenly distributed rewards. So that's something we think will be also very attractive to miners.
And I guess so. In your case, the token incentivization is part of becoming a node in a high processing network. That's the incentive to mine or to have tokens. How does that relationship between the kind of the token and the using the technology itself as a kind of end user or end developer relate to each other?
So for end users who need to use a blockchain to run, let's say, applications, right? Because number one, our sort of electrical cost for running miners will be much lower, and number two, because every second we are processing thousands of transactions, that means the average cost, this gas cost for each transaction will be way lower than today's blockchains. So that could be very useful for applications. So one typical application who will be benefited from this is, let's say, micropayments, right? Because the surcharge for making a payment will just be much lower, and it will be much faster. So this is also an interesting aspect of our blockchain design.
I think this is one of these aspects where I sort of try to constantly think about how especially high performance blockchains can be used for use cases that aren't just kind of financial related. Because that's one of the very obvious use cases, of course. But could you see, for example, at the moment, if I wanted to do some high performance machine learning processing, I might spin up some AWS instances or some Azure instances, and of course I pay for the usage. Could you foresee your platform being used in a similar way? Like, I want to do some machine learning processing instead of firing up cloud instances. I acquire some tokens to the Zilliqa network and I use it instead.
Yeah, you can do that. People will definitely do their own comparison financially, right? So if it's cheaper, they'll be happy to run this on Zilliqa. But more importantly, the benefit of running some computing tasks on the blockchain is like, if you require sort of higher assurance, then the blockchain will provide that, because blockchain is all about redundant checks or redundant validation. So if you want your same function to be computed twice or three times on the blockchain, then Zilliqa can provide that. So this is some flexibility. If you look at today's blockchain, you don't have that flexibility to the applications, because you either write just on a node, or you have to write on almost all nodes. Then if you want some redundant checks, but not all the nodes running the checks, because that's very costly, you really can't do it. So that's something called security budget. We talk about in our white paper.
And actually, what's the sort of impact of using blockchain or blockchain-like network for reading back that information? Often a lot of distributed systems focus on write, and sometimes the read can be a little slower depending on the size of the query. But are you comparable to some of those distributed databases when it comes back to reading information? Or are you also focusing primarily on the write?
We have not, sort of investigated too much on specific fast read requirements. But on the other hand, we are going with this account-based model. So that means if you just want to, check the balances of the account, I think it should be pretty fast, because all the nodes will have the information.
Okay. Just at a complete side issue, I noticed right at the top of your token generation announcement, there's a very bold statement saying not for distribution in the United States, the United Kingdom, China, or Japan. Why is that? Just out of pure interest.
So, that was sort of the legal advice received, regarding different potential jurisdictions in different countries. I mean, there's no discrimination per se. For sure, we want our tokens to be popular among, everyone in every country. We want the system to be available to everyone.
No, for sure. It was just an intriguing thing to see.
Yeah.
Okay. Yeah. So, and then actually, so we've already talked about a little bit about the roadmap. Testnet version 2 is coming probably in the next couple of months. A mainnet a little bit beyond that. And then towards the end of the year, you're looking at DApps, Anchor DApps, so decentralized applications. I mean, firstly, I guess, what's behind the name Anchor? And secondly, what sort of use cases do you expect people can implement with your dApps or dApps, however you want to pronounce it.
Yeah, I mean the question is how are they going to develop the apps or?
Yeah, how will they release? How will they develop and release them? What will they be able to do in comparison to other decentralized app systems and protocols?
Uh, yeah, I think it will be similar, So, for example, when we have our next version of the testnet, probably people can already start, coding smart contracts on our platform. So they can start doing some testing on our testnet, and then when we convert to our mainnet, the transition should be smooth because from our testnet to our mainnet is, it's just about stability or things like that. Really, the interfaces should stay the same. So, I don't think it will be too different.
And actually, just as whilst we're talking about names, I love the name for your token, the Zillings, which I don't know if anyone's not aware. I mean, there's actually quite a few currencies with the shilling, and the old pound used to have the shilling as well. So it's kind of, I don't know if you realized that when you did it, but, but it's kind of a cool reference back to that. Anything we haven't spoken about that you want to make sure is mentioned about the technology, the platform, the team that you want to make sure is mentioned? Okay. And just as a side question, like, what's it like running a blockchain project and a tech project in Singapore?
I would say, Singapore has a sort of friendly environment in terms of regulation. And then people are also getting excited about the blockchain. But of course, it's a relatively small country. You also have to think about how do you make your project global, right? You need to think about how do you get more people aware of your project so they get excited outside Singapore as well. So, that's some of the things we're working on now.
And what do startups and projects in Singapore tend to do? Do they tend to look more towards Asia or towards the US or Europe or a bit of everything, or it depends?
I think it depends, right? Different projects we have their different focus groups to target. For us, we are a platform builder, so clearly we want to just get this platform across every country. Of course, because we are in Asia, so we will probably do more in Asia to begin with. But really, that's about just to get things started. In future, we will also try to expand to Europe and US as well.
I mean, Singapore is always in a somewhat unique position in possibly Singapore, Hong Kong, and maybe Australia, New Zealand, kind of these weird like gateway countries in Asia. They're sort of in Asia but have close connections to the West as well, which give them a sort of an easier way, I suppose. I mean, like, obviously, I think Singapore is one of the countries that is fairly favourable to blockchain specifically, especially like it's like the sort of Asian Luxembourg and Switzerland. But are there any negatives? I mean, Singapore also has a reputation for sometimes being, and obviously I'm fine if you don't want to talk about this, but sometimes having heavy-handed regulation in other things. Is there any times when it's hard to run a startup in Singapore? Cost of living or regulations or?
I think one challenge many people face in Singapore and of course in many other countries is hiring the best talents, right? So that's always difficult. There's always a shortage of good talents, especially when we are, a high-tech company. We are looking for very specialized people who understand computer systems, computer networking, or things like that. So that's just, a little challenging. But we are okay. We are even quite successful, I would say, in terms of finding, these few talents. So, but in general, I think the thing is changing. So now more people want to understand tech. More people want to, work for tech.